Greetings everyone, I'm Dr. Jan from the Kulanaya Foundation. Welcome to chapter 2 of the Sound Waves and Whales Today unit that we're talking about. Today we're going to explore why sperm whales make such loud sounds. So let's get started. Why do sperm whales make loud sounds? Sperm whales make some of the loudest sounds of any animal. Making loud sounds takes a lot of energy. But animals don't waste energy, so sperm whales must have a good reason to make loud sounds. Remember that louder sounds have more energy and higher amplitude. We experience high amplitude sounds as being loud. Acousticians describe and measure loudness by using the term intensity. But before we continue with this, with measuring sound, we need to talk a little bit about standard unit of measure. It's easy to understand if we talk about temperature. So let's talk about temperature first. People can be very subjective in how they feel temperature. Think about how you feel on a spring day. Some people would say that it's warm, other people would say that it's cool. But if you had a thermometer, you can measure temperature and you can agree that, for example, if it says 40 degrees on the thermometer, then that's the temperature it is. Scientists have developed different scales for temperature in different countries. So 40 degrees means very different things depending on the scale you're using. You need to know if you're measuring temperature in Fahrenheit or Celsius, for example. 40 degrees Fahrenheit, as I said, some people think it's warm, some people think it's cool, but 40 degrees Celsius, everybody will agree is very hot. And that is because these scales have different reference points. For the Celsius scale, the reference is when water freezes. That's set to 0 degrees Celsius, and that happens to be 32 degrees Fahrenheit. The Fahrenheit scale, on the other hand, has a reference point of 0 degrees for a brine solution of water when that freezes. That's about minus 18 degrees Celsius. So to measure sound wave energy, we also need a unit of measure. You already know that a high amplitude wave has more energy than a low amplitude wave. But how can we measure how much more energy? We need standardized units of measurement that everyone can agree on to be able to compare different sounds from different sources and different recordings. So scientists use a unit of measure for intensity that they call decibels, or dB for short, to measure sound. Sound intensity is measured in decibels, and it measures the pressure that a sound wave exerts when it hits a surface. Now, this is different depending on whether we're looking at sound waves in air or sound waves underwater. So we're going to look at a film clip.
Sound waves in water and sound waves in air behave differently because of the physical differences between air and water. The intensity of a sound wave depends not only on the pressure of the wave, but also the density and sound speed of the medium through which the sound is traveling. Sounds in water and sounds in air that have the same pressures have very different intensities because the density of water is about 800 times greater than the density of air. Sound levels given in decibels in water are not the same as sound levels given in decibels in air.
Not only are sound intensity measurements different because air and water have different densities, but also because the reference points are different for the two mediums. So to answer our question, why do sperm whales make loud sounds? We need to develop an explanation based on evidence. So let's review what we already know about sound waves. Because water is denser than air, sound waves travel much faster in water than in air. Intensity, measured in decibels, measures the pressure of a sound wave hitting a surface. Sound waves with the same intensity in decibels have more energy in water than in air. So you have to be careful when you compare the intensity of sounds in the two mediums. We will focus on measurements of intensity in decibels of sound in water. We're going to pause now so that you can go to a wave app and have a chance to observe simulations of sound waves as you change the amplitude and frequency. Take careful notes in your notebook of your observations. Be sure to observe how the intensity of the sound wave changes as it moves away from the sound source. I'll be back in a bit to explore sperm whales and loud sounds. Good luck.